Welcome to another episode of Earth is Our Spherical Home Planet by the Robinson Twins. I'm Bob.
And I'm Rick.
And this is our home sweet home.
Okay, we are at the Kugel Fountain at the Amtrak station in Bakersfield, California. And here's a sphere that represents the Earth. Now, why can't the flat earthers and space deniers keep asking, why can't we see satellites from the ISS from the live stream? Well, here's one of the reasons why. This is our simulated distance to scale distance from this Earth representing sphere to what would be a geostationary orbit where the camcorder is. So now I'm going to show you what the view from there looks like looking at the Earth. And this is the kind of satellite that people with cable TV or satellite TV use and have to aim their satellite dish at it because it takes a whole 24 hours to go around the Earth once, just like the Earth does, so it appears to be stationary. And the orbit for these satellites is, what did you say, 35,000 kilometers. 35,000 kilometers. So this is to scale 35,000 kilometers from that. So the scale we're figuring on from that size representation of the Earth, 6 meters away from it represents the distance that a geostationary satellite would be from our Earth. And this is the view. We'll show you the view from this camcorder looking at that Earth from this height. You see there's a lot of space in between these two things, so any satellites below there are some distance away, and it would be hard to pick it up with even a good camera. So why would people expect to see satellites all over the place? And so again, if this represents the Earth and the ISS's orbit is only 5.5 centimeters to the scale, then of course you're not going to see satellites that are way over that way. Okay, we've measured the circumference of this kugel fountain sphere. We figure the diameter is about 1.8 meters, and so what we wanted to do is scale that to what the ISS's orbit over the Earth, the International Space Station's orbit over the Earth would be. It's 400 kilometers, which at this scale comes to about 5.5 centimeters. So relative to this sphere, that's how high the ISS is above the planet, above Earth. So this simulates the view from the ISS. 5.5, and here's the view. So you can see it can't see very much of the Earth at any one time. Not at 5.5 centimeters worth as we see on this sphere. And that's where you'd have to look to see a geostationary satellite. Again, this is about 5.5 centimeters. No, it's about where I have the GoPro lens. So this approximates the view from the ISS as it passes over the Earth in its orbits. As opposed to seeing the whole Earth from much higher up, as would be the case of geostationary satellites. Five and a half centimeters on this sphere.
So you can go on YouTube and watch the ISS live, and in the screen you can see the camera on the ISS is looking straight down at the Pacific Ocean, and then the lower left you have animations showing where it is in its orbit. You can see it's approaching the south end of South America. And then on the right hand side you have a more detailed animation showing where it is, because there's no satellite looking down on it that could record it, so anybody who expects there should be one is being ridiculous. But here it's approaching this Chile and Argentina south end, and they're looking straight down at the Pacific Ocean. You can see clouds, and in a little bit we should be able to see it looking down on the Andes Mountains. Unfortunately, we have part of the space station is blocking the view of the camera looking down, but it's now approaching the coastline of South America, looking at the Andes Mountains. So the ISS is traveling at 17,500 miles per hour approximately, and takes about 90 minutes to complete one orbit around the Earth. So it's orbiting the Earth about 16 times per day. So if you're on the space station, you'll be able to see 16 sunrises and 16 sunsets. And here is Chile, looking down on the Chile and the Andes Mountains, and then on into Argentina. Spectacular views from up there, 400 kilometers above the Earth. We've watched the ISS pass over our locations on many occasions and recorded a couple of times. We have one on our YouTube channel, and we'll link to it in our description.
6 meters away from it represents the distance that a geostationary satellite would be from our Earth. And this is the view. We'll show you the view from this camcorder looking at that Earth from this height. And you see there's a lot of space in between these two things, so any satellites below there are some distance away, and it would be hard to pick it up with even a good camera. So why would people expect to see satellites all over the place?
Satellites are put in different orbits depending on their function. The LEO, or low Earth orbit, is where the space station is located. And then there's the sun-synchronous orbit, where the satellite goes over the poles. A medium Earth orbit, or a little bit higher up. The geosynchronous transfer orbit, which is usually temporary. And then the highest, the geostationary orbit, which is the one we simulated. Satellites can vary in size from smaller than a watermelon to as big as a pickup truck or even a small school bus. Satellites have a wide range of forms and functions. Mainly they're for communication, weather observations, and navigation. The U.S. has launched 83 GPS satellites since 1978. The United States currently has 31 operational GPS satellites. Russia has the GLONASS system, 24 operational there. Galileo is the Europe's GPS satellites, 24 of those. And China has the Beidou. They've got 27 operational satellites. All the satellites in orbit are being tracked, so when a new satellite is launched, it's put in a place that won't conflict with the existing ones. So they maintain a good spacing between them, and there's lots of distance, hundreds if not thousands of kilometers between them. And a lot of satellites don't even have cameras on them, like a GPS or radio communication satellites don't have cameras on them, so they wouldn't be able to look at other satellites in the area. And even if they could, there are satellites that range in size from as little as the size of a cell phone to a suitcase, to a small car, to a pickup truck. You wouldn't expect to see a pickup truck 200 kilometers away, of course. So all these space deniers who try to say, where are all the satellites? How come you can't see other satellites? Just don't understand the issue. I hope that we manage to clear that up for you. Here's a view of Earth from a geostationary satellite, the Geostationary Operational Environmental Satellite System. Space deniers try to claim that there's no satellite that can get an image of the entire Earth at once, but here it is. The geostationary satellite gets images of the Earth every 15 minutes, and you can put these together into a time lapse.
Thanks for watching. Now be sure to hit that like and subscribe button if you like this kind of content. And hit that notification bell too. We'll see you in the next one. Earth is our spherical home planet. And good planets are hard to find.